Okay, yesterday we talked about the discriminant and how to use the quadratic formula to solve quadratic equations, but we focused on solutions that were real, not complex. So we're going to do a little bit more practice today, focusing on those complex solutions. So here's a refresher. There's a video to help you remember the song. There's some notes there to show how the quadratic formula is derived. I'm not going to go through that now. We're going to follow these steps. Okay, so we are going to solve using the quadratic formula. So the first step you will recall from yesterday is that it has to be equal to 0, and that's not listed there. I should add it. We're going to go ahead and do that. So I end up with 2b squared minus 8b minus 22 equals 0. And for my first step, I'm going to find the discriminant. So the discriminant is b squared minus 4 times a times c. So we're going to go ahead and type that in. So negative 8 squared minus 4 times 2 times negative 22 gives me 240. Okay. Second step is to go ahead and simplify that. So if I take the square root of 240, I can break that down as, let's see, what goes into 240? Let's do 16 times 15. Largest perfect square that goes into it. So it's really 4 square root of 15 there. And then if I plug this into the quadratic formula, that's my answer there. Plug this in the quadratic formula, we end up with the opposite of b plus or minus the square root of our discriminant. So we got 4 square root of 15 all over 2 times a, which is 2. Okay, and this goes into step 4. Go ahead and simplify. And then notice I can reduce all of these numbers. So we're going to go ahead and I'm going to highlight them. And this only works when it's these three, never with the inside. Okay, so 8, 4, and 4. I can divide all those by 4. I'm not going to deal with that 15 at all. I'm going to leave it as it is. So if I divide everything by 4, I get 2 plus or minus 1 square root of 15 over 1 for a final answer. Okay. That one didn't have an imaginary number in it, but it did have a radical that we had to break down. Okay. Let's do another one. Second one. There's some extra notes in there. We're going to ignore this because we are not going to worry about completing the square. We are going to find our discriminant. So the opposite of, sorry, not the opposite. We're going to do b squared minus 4 times a times c. Step 1. When I plug that in, I get negative 252. So I know I'm going to have some imaginary numbers here because that's negative. So we're going to go ahead and see if we can break that down. 252 breaks down to 52 divided by 36, I believe. Should work. So this is the same as the square root of negative 36 times 7. So I get 6i root 7. And then I'm going to go ahead and plug it into the quadratic formula for the rest of the problem. So quadratic formula is the opposite of b plus or minus the square root of the discriminant, which we got right there. So 6i square root of 7 all over 2 times a, which is 8. And then moving into step 4, we're going to go ahead and simplify. So 2 times 8 is 16. And then I'm going to check these three numbers to see if I can reduce by anything. And I can. I can divide them all by 2. So I'm going to get p equals, if I divide by 2, I get negative 1. 6 divided by 2 is 3. And 16 divided by 2 is 8. So there's my reduced solution. Go ahead and try these next two problems, and then you can go ahead and work on your work.